Hello and welcome back to biology. So we're going to kind of wrap up our respiration part of this unit today by talking about fermentation. So up to this point, we've been talking about the aerobic pathway, what happens if there is oxygen available. But there's some bacteria out there, and even us, even all living things, what if we don't get oxygen or have enough oxygen available? Well, then we go to the anaerobic pathway, which is fermentation. So all fermentation is its use of pyruvate. So remember, pyruvate's what we get at the end of glycolysis when glucose breaks apart into 2,3 carbon compounds. That's pyruvate. So we're using pyruvate then to make a minimal amount of ATP. And this happens when, again, there's not enough oxygen to be available, or just some organisms just don't use oxygen at all. So there's two different types of fermentation. There's lactic acid fermentation and there's alcoholic fermentation. But fermentation, this is going to happen outside of the mitochondria. So this is going to stay in the cytoplasm. So glycolysis already happens in the cytoplasm, and then we're just going to keep staying out of the cytoplasm. So there's two different types, lactic acid, alcoholic, and they're named after their byproducts. The lactic acid fermentation just makes lactic acid, and so we call it lactic acid fermentation. Alcoholic fermentation produces ethanol, which is alcohol, and then some carbon dioxide. For alcoholic fermentation, yeasts are going to do it. They're the most popular one. And then some anaerobic bacteria, including us, we will do lactic acid fermentation. So in lactic acid fermentation, we turn pyruvate into lactic acid. If you've ever done any sort of physical activity or exercise, after a while, or even start right away, like your muscles start to burn. There's that burning sensation in your muscles. Well, that's that lactic acid there. So for us, we don't rely on it, but we can kind of use it as like a boost button or a turbo button. Whenever we need just a little bit more energy quickly, we will quickly do lactic acid fermentation. So lactic acid is actually harmful to the body. So if too much lactic acid burns up, eventually it can cause a cramp. So like your body will literally kind of stop yourself from pushing yourself too hard, cause a cramp to get that lactic acid out of the muscles, because it is harmful to the body. Alcoholic fermentation is just like what it sounds like. We use yeast and bacteria, turn pyruvate into ethyl alcohol, which is how we get wine and beer and other alcohols that we drink. So before we talk about the fermentation, just a little recap about glycolysis. So glycolysis, we're turning glucose into pyruvate here, and along the way we get 2 ATP is made right here. Well, we make 4, but we use 2, so we really say we get 2 ATP from this process. We also make 2 NADHs and 2 pyruvates. So the problem is that glycolysis can run kind of forever as long as we have a supply of 2 things. As long as we have a supply of glucose and a supply of NAD+, we can just kind of keep running glycolysis over and over and over again. But the problem is, though, is in the aerobic pathway, NADH turns back into NAD+ during the electron transport chain. But if there's no electron transport chain happening, well, NADH isn't going to turn back to NAD+. So eventually we're going to run out of NAD+, and we're going to stop doing glycolysis. That's what fermentation solves, as fermentation solves this problem here. So the whole goal of fermentation is to turn NADH back into NAD+. So if we look at the two types here, lactic acid fermentation, they're just going to convert pyruvate straight to lactic acid, and in that process, it's going to turn the NADH that was made here back into NAD+. And then that NAD+ can go back to glycolysis and keep running. Alcoholic fermentation is going to serve the same goal. We're going to turn pyruvate into ethyl alcohol, and in that process, we're going to turn NADH back into NAD+. The only kind of extra thing with alcoholic fermentation is ethyl alcohol is a 2-carbon compound, where pyruvate's a 3-carbon compound. So we do lose a carbon, and that carbon is going to get attached to oxygen to make carbon dioxide. So these are the pathways or the equations down here. So for lactic acid fermentation, glucose, because there's no oxygen, so just glucose will make 2 lactic acids and 2 ATPs. Alcoholic fermentation will turn glucose into ethyl alcohol, 2 ethyl alcohols, 2 carbon dioxides, and 2 ATPs. All the 2's just come from the fact that since we have 2 pyruvates, it happens twice. So the whole goal of fermentation, so we don't actually make ATP during fermentation. Our fermentation is just there to keep glycolysis running. So the whole point of fermentation is just to help glycolysis to keep running by converting this NADH back into NAD+. So that's the whole point of it. We've done great things with fermentation. We've taken great advantage of it. A lot of our common foods that we eat are actually made from fermentation. Besides the obvious with alcoholic fermentation and alcohol, vinegar is made from fermentation. Any sort of cheese is made from fermentation. Sauerkraut bread is made from fermentation because you add yeast to bread. Now, no, bread is not alcoholic because what alcohol is made is baked off, but without yeast doing fermentation, we wouldn't have bread, we wouldn't have cheese because cheese is made from lactic acid fermentation. So there's tons of foods that we eat that takes advantage of fermentation. So that's it for fermentation. Let me know if you have any questions. I hope this was helpful. Have a good day.